In this second item of the series, we show how to check more precisely the data and control dependencies in a Spark program. Instead of simply checking which data is read and written by subprograms, we also check which inputs are used to compute each output of a subprogram. Switching from data flow to information flow analysis only requires adding derives annotations to subprograms and running the examiner in information flow mode. Like we did for data flow analysis, we can start by considering the specification of database. Derives annotations allow specifying which input values have an influence on the determination of an output value of a subprogram. An input-output value can be a parameter, a global variable, or a logical piece of state. As before, we can run the examiner to check that the annotations are valid. Looking at the derives annotation for subprogram addAccount, we see two lines, one for its out parameter account and another for its in-out global piece of state identity data. The annotation specifies that the account number generated should only depend on the current state of identity data, and that identity data should be updated based on its initial value plus the value of the procedure in parameters. Here, the examiner already checks the consistency of these annotations so that no input or output of the subprogram is forgotten. Suppose we remove customer from the annotation this is detected by the examiner. A convenient shorthand in these annotations is to refer to the variable on the left of a from with the star character on the right, like we've done in the annotation of delete account to refer to identity data. Notice that the function balance does not have a derive annotation. Indeed, the only output of a function in Spark is its result, because a function is not allowed to write global variables. Thus, there is an implicit derive annotation that the result of a function is derived from all its inputs. Let's now switch to the implementation of database. Like we saw for global annotations, derives annotations must be stated here in terms of concrete variables. Looking at addAccount, the dependency for parameter account is refined, and the dependency for identity data is now expressed for each component of this logical piece of state. The examiner checks both that the derives annotations on the body refine the ones on the spec, and that the implementation respects these annotations. Any modification of the annotations which is not consistent with the code is detected by the examiner, and vice versa. For example, if we change the annotations, the examiner detects it, and if we change the code, the examiner also detects it. So to summarize what we've seen, the Spark language allows a detailed description of the flow of information in a program, taking both direct and indirect flow into account. The examiner tool checks that the abstract and concrete view of these flows are consistent and that the implementation respects the specified flows.